Hello again. We are continuing our discussion of linear equations by talking about how to solve one-step equations. Alright, so let's look at an example. If 2x equals 8, then what is the value of x? So basically I'm multiplying a number by 2 and getting 8 as my answer, and I want to know what that number is. So let's look at a picture of what we have, even though you've probably already figured it out by now. When I have 2x, each of those long bars is going to represent the value of x. So I've got 2 of those on the left, and then I've got 8 ones on the right. So that's typically how I set up an equation using what's called algebra tiles. Okay, so the left side is equal to the right side. I know that because of the equal sign. So I consider the same portion from both sides, and if I do that, they'll still be equal. So I'm going to look at half of each side. I can do that, and they will still be equal. So if I divide both sides by 2, represented by that dotted line there, half of 2x is just x, and half of 8 is 4, so that means that x is equal to 4. Okay, so that's an example of a one-step equation. Here's another one. If I have 3 times w equals negative 18, what's the value of w? So 3 times some number is negative 18. What's the original number? So there it is represented. I've got 3 w's on the left, and I've got 18 negative 1's, which is worth negative 18. All of that is on the right. 1 w is actually worth 1/3 of what is already on the left. And so if I look at what's 1/3 of each side, then I can solve the equation. So basically I'm dividing both sides into 3 equal parts. 1/3 of w, or 1/3 of 3w is just w, and 1/3 of negative 18 is just negative 6, so that means that w is negative 6. Okay, here's a slightly different example. I've got y plus 2 equals 7. What's the value of y? Again, they're equal. We were told that they were equal. So there's 2 extra 1's on the left. So I need to get rid of those so that I get that y bar by itself. So I take 2 1's off of each side. And if I do that, I subtract 2 from the left, I get just y. And if I subtract 2 from the right, I get 5. So that means that y is equal to 5. Okay, a tricky one. If I have g minus 3 equals negative 1. What's the value of g? So what would I have to subtract 3 from to get negative 1? So there's 3 extra negative 1's on the left. I want g by itself, but those 3 negative 1's are in the way. So I need to subtract those 3 negative 1's. But the problem is I don't have 3 negative 1's to subtract on the right, even though I do on the left. So what I can do, there's another way of getting rid of 3 negative 1's, and that's to add 3 positive 1's, and that will give me g minus 3 plus 3. Okay, so each one of those positive 1's cancels with a negative 1. So now g is by itself, and now I have to do the same thing on the right and add 3 positive 1's. And what will happen is one of those positive 1's will cancel with the negative 1 that was already there. So now I just need to look at what's left. I have g on the left, and I have 2 positive 1's on the right, so that means that g is equal to 2. Okay, so here's a summary. Whenever the variable on the left is being multiplied by 2, that means I need to divide both sides by 2. When the variable was multiplied by 3, I divided both sides by 3. When 2 was added to the variable, I subtracted 2 from both sides. And when 3 is subtracted, I added 3 to both sides. So whatever's happening to the variable, look at what other operation and whatever number is also on the same side as the variable, and you're just going to do the opposite of what that operation is with that number to both sides. Okay, so if I was given x plus 4 equals 7, what should I do? Well, I have a plus 4 that's on the same side as the x. And what's the opposite of adding 4? Adding negative 4 or subtracting 4. You could also subtract 4. It means the same thing. If you're given 5p equals 120, well, p right now is being multiplied by 5. And what's the opposite of multiplying by 5? Dividing by 5, so we're going to divide both sides by 5. If b divided by 6 is equal to 3, well, what's the opposite of dividing by 6? Multiplying by 6. If r minus 8 is 1, well, r has 8 being subtracted from it. What's the opposite of subtracting 8? Adding 8 to both sides. So you kind of get the idea. If t plus 7 is 2, the opposite of adding 7 would be adding negative 7 or subtracting 7, however you want to think about it. So here's a word problem. I have a large stack of 7-cent stamps, and they are worth a total of $1.61. How many stamps do I have? Well, I'm going to let S represent the number of stamps that I have. So 7 cents per stamp times the number of stamps would be 161 cents. So that's how I write it. Okay, and since s is being multiplied by 7, then I need to divide both sides by 7. Okay, that means that s will equal 23. 161 divided by 7 is 23. So that means I have 23 stamps. So that is one-step equations in a nutshell. If you have any questions, please let me know, and I will see you tomorrow.